In this open response question, Cody gets a haircut and his hair grows back at the rate of 3 millimeters per week. And what we have to do is complete this table of values. We have to determine what is the rate of change of hair growth, what is the initial value, and then write an equation that represents the linear relation between where L is the length of Cody's hair in millimeters and N is the number of weeks since the haircut. Well, the first thing we can do is we can say, well, this column here is N for the number of weeks since the haircut, and this column here is L for the length of the hair in millimeters. Well, the first number to look at would be this one right here. And to answer the question, what would the length of the hair be right after the haircut? Well, if the rate of growth of hair is 3 millimeters per week, and after 1 week his hair is 4 millimeters long, then right after the haircut his hair would have been 3 millimeters less than 4, or 1 millimeter in length. And what we can see here in terms of the relationship is as the number of weeks goes up by 1, the hair will grow by 3 millimeters. Well, let's continue the pattern and say as we go up by 1 more week, the hair should grow by 3 millimeters. It's a linear relation. So after 2 weeks, 4 plus 3 would leave us with hair that is 7 millimeters long. Now, the next thing we notice is actually when we go from 2 to 5 weeks, we're not going up by 1 week. We're actually missing some weeks here. Well, one of the things we can do is create a separate side table of values and just add those missing weeks in. So we could write N for the number of weeks since the haircut. We can write L for the length of hair in millimeters. And we know right after the haircut, his hair was 1 millimeter long. After 1 week, it was 4. After 2 weeks, it's 7. So let's find out for 3, 4, and 5 weeks what the length would be. So on the left side, if we increase by a week each time, then we increase the length by 3. So for week 3, this would be 7 plus 3, or 10. Then for week 4, it would be 13. And then for week 5, it would be another 3, or 16 millimeters long. And our relation here is we're increasing by 3 each time. So we can put the value 16 in here. You can do this another way too. We could say the difference between 2 and 5 weeks is plus 3 weeks. Therefore, 3 millimeters a week would be 3 times 3, or up 9 millimeters in length. And then 7 plus 9 would leave us with 16. But if we look at this table of values, we can see the consistency here, that for every week that we go up, the hair grows by 3 millimeters constantly. So we know the rate of change. The rate of change is 3 millimeters per week. So we can write the rate of change is plus 3. Next, we have to determine the initial value. And that initial value will be where we started. So right after the haircut, the height of the hair was 1 millimeter. So our initial value is 1 millimeter. Next, we have to write the linear equation that represents this relationship. Now, we have 2 variables, N and L, and what we have to determine is which one is dependent on the other. Well, in this case, L is the dependent variable because the length of the hair depends on how many weeks have passed since the haircut. So in general, the equation of a linear relation is the dependent variable equals the rate of change times the independent variable plus the initial value. So here we go. What's the dependent variable? Well, we know it's L, so it's written right here. L equals, there we go, the rate of change. Well, we can write in 3 here. Positive 3, we'll just forget the plus sign, we know it's 3, times the independent variable, which is n. So we multiply this by n, and we can write that as 3n, plus this value here, the initial value. Well, the initial value is right here. It's the 1. So we simply say plus 1. And there we go. There is the equation for this linear relation.